Alright guys, this is Jimmy. So in the last video we talked about the very important problem, LRU Cache. So we implement the LRU Cache using a hash map or dictionary and a queue, so that supports ON operation. And then in order to make it faster, to answer the follow-up question here, so we used a data structure called ordered dictionary in Python. So in the ordered dictionary supports move to end, and also it supports to pop item either from or from either from or from the very last item. So those operations are all O1, so that's very good. How about however, if I ask you this question, how about do not use this very specific, very special data structure called ordered dictionary? How about just use very normally used data structure? How to do that? So in order to do that, we should know that we need to do it in O1 operation. So in order to do that, so remember we implement the ON operation using a queue, right? So if we use a stack, it will also be ON. If we just use a list, any sort of list, linear list, array list, it will always be ON. Note that in data structure, there is this one data structure linked list that does not require linearly continuous store of data. So the delete, the replace, the move, the delete operations are all O1 for linked list. So how about we implement the ordered dictionary using a linked list? Here we actually use a doubly linked list. So we need to firstly make a new class double linked list. Double linked list is a very useful and very common data structure. We should really learn how to use them, because they are really handy and very important. Key value self key equals key, self dot value equals value, self dot next equals none, self dot previous equals none. Okay, now that we have a double linked list, we need to define a dummy head and a dummy tail. So self dot dummy head equals double. So defining a dummy head or dummy tail is just for making things easier to operate in linked list. They are really handy. We should also know how to use them. So double linked list. We can set whatever value we want because we are not going to use those values. Self dot dummy tail equals dummy tail equals double linked list 0 0. We should hook up the dummy head next equals dummy tail pre next equals dummy tail self dot dummy tail dot pre equals self dot dummy head. So they are hooked up, so that's very good. And we need to self dot still need a cache equals the cache. So the key is the key is the key. The value is the node. The value is a node. The key is actually the key that were used to get and put here. So here the value is the node. Okay. So that's good. Self the capacity equals capacity. So that's good. Okay. Let's now implement get self dot no, if key not in self dot cache, then we should return -1, else then we should return cache. Key. Note that key, the value of the key corresponds to the node. So node dot value. So that's what we need to return really. So but before return that, we should move the key to the tail of the double linked list. Okay, note that the most recent used one is at the it's put right before tail, while the list used one is put right after the head. Okay, so after we get the key, we should put the corresponding node to the tail. So we should self dot so the node equals self dot cache key. So we should really say this is node. So node equals this, and we should move to tail self dot node. Move the node to the list, linked list. Okay, so now here we used a function called move to tail. So we need to, later on we need to define self dot move to tail self node. Okay, currently we just say pass. We finish the main function first, then we deal with this helper function. Okay, now we implement this put function. If key in self.cache, then we should really update the value of the cache. So self.cache key, it's a node, so it has a value equals value. Now the value is updated, and we should move to tail, move the node to tail. The node is self.cache key. Okay, now if key is not in cache, now if the key is not in cache, then we should make a new node equals double linked list. Double linked list. New node should have a key value. Now we have a new node. We can append the new node to tail. Okay, so append the new node to the tail of the linked list. How to append that? Self dot put to tail, or insert to tail. Let's say just insert to tail new node. If the length of cache self.cache is larger than the self.capacity, then we should pop something out, right? We should pop, so we should remove self.remove from head. Which node should we remove from head? That's a good question. So which node, the least used node, remove from head? Okay, the least used node, least used node equals self dot dummy head dot next. So that's the least used node. So we should remove the least used node. You know what, we can just say remove, doesn't need some remove from head. We can just say self.remove least used node from the linked list. Also, we need to delete self.cache the node, which corresponds to the key. What is the key? The key is the list used node dot key. So that should do it. So that's the main function. We should always make a good habit that we finish the main function first, then we go to the helper function. So helper function is normally shorter. So let's do the helper function first. So this help function is remove. That's probably easier, the most easy one, the easiest one. Define remove self. Okay, we remove a node. Then in order to remove a node, we should say node dot how to remove a node. Let's draw something to see how to remove a node. Okay, remove should be, so okay, we have a node here. This one is the previous one, prev1. This one is the next one. So in order to remove the node, we should hook the previous one directly to the next one, and then hook the next one directly to the previous one. So that's node.prev.next equals node.next node.next.prev equals node.prev. Okay, that's removed. Then we go to self.move to tail. So it's right here. We need to move to tail, and also insert. Let's just insert to tail first, because that's easier. Insert to tail. Self node. Insert a node to tail. So how to insert a node to tail? How to insert a node to tail? So here is the tail. It has its previous one. They're hooked up like this. Now we want to insert a node to it. So firstly, we put the previous one here. Hook up the node with the previous one, like this. And then hook up the node with the tail, like this. We may or may not need to use the temp. Let's see. Okay, tail.prev.next equals node, and node.prev equals tail.prev. So that hooks up the node and the prev. Now let's hook up the node and the tail. So tail.node.next equals tail, and tail.next equals tail.prev equals the node. Let's see if it works. Firstly, tail.prev.next equals node, then node.prev equals tail.prev, then node.next equals the tail, and tail.prev equals node. So that looks good. So move the tail. Move the tail should move a node to tail. So the first step is to remove the node, and then the second step is to insert to tail the node. Insert the node to tail. Then in that way we move it to tail. So let's have a look at the total logic here. Define a double linked list. Define dummy head and dummy tail. The most recent used one is put right before the tail, while the least used one is put right after the head. Okay, hook up the head and the tail. The cache and capacity. For the cache, the key is the key, or the value is the node. So remove the node, insert tail, move the tail. So get, if the key is not in cache, return -1. If it's in cache, then we should find the node and then move the node to the tail. Move the node to the tail of the linked list and return the node value. And if the key is inside the cache, then what should we do? If we we just update the value of the key and we move the node to tail. Okay, if it's not in the cache, then we need to make a new node because the node is not in the cache. Make a new node with the key and the value, then insert. Wait a second. We make a new node and we should put node into the cache, right? Self.cache key equals new node. Then we insert the new node to the tail of the linked list. However, if the length of the cache is larger than self.capacity, then we should pop something out, pop the list, use the node out. What is the list used node? It is the node right next to the dummy head. Then we remove the list used code from the linked list and also delete it from the cache. That's probably right. Let's just run it. Okay, tail is not defined. Where is it? Okay. Oh, right. Should be dummy tail. Sorry. Self.dummy tail. Self.dummy tail. Self.dummy tail. Self.dummy tail. Self.dummy tail. Okay. Should be good now. Non-type has no attribute. Next. So node.prev. Okay, remove non-type. So to remove it here. So we're removing the non-type. Why we are removing a non-type here? Let's see. I don't think. Oh, maybe we are. It does not necessarily be here. It might be here though. Let's see. 922, 933, 22, 33. I was here. Move to tail. That's something wrong. So 41. So something get here. 41. Okay. Move to tail. Node. Get the node equals the cache key. Okay. Then move to tail. Node. Move to tail node. The node should have prev. The proof doesn't have next. Node doesn't have next. Node doesn't have next. No. Node should have next. And node should have prev. And node.prev should also have next. So that's kind of weird. What happened here? Okay. So why there's something wrong here? Let's see. Oh, there's a typo here. But that should not be the problem. Should not be the problem. we didn't put, we put it right. We put it. We have put that in it, so that should be okay. Insert to tail, that should also be okay. I don't know. Let's have a look. Huh. So that's the problem of the typo hit there. Okay, let's just hit submit. Good. This is very good. So we successfully implemented LRU using a DoubleLinkedList and a hash map or dictionary, which is very, very cool. I think I really like this work, and I really like this video. If you also really like this video, please subscribe to my channel, or share my video to your friends, or just upvote it. This is Jimmy. Thank you very much. Bye bye.